Welcome to Algebra 1, Chapter 9, Section 5, Completing the Square. Let's review the vocabulary of square roots. Every positive number has two real square roots. The square root symbol is also known as a radical. The square roots of 121 are 11 and negative 11. As a review, let's factor these four equations. Think about, as you factor these, what their outcomes are, because each of these are a special type of trinomial. So now pause this video, factor these, and then restart this video for us to talk about them. Our vocabulary word is perfect square. A perfect square is a number that can be written as the square of an integer. For example, 16 is a perfect square because 4 times 4, 4 squared, is 16. The expression x squared plus 10x plus 25 is a perfect square trinomial. X squared plus 10x plus 25 can be written as the quantity x plus 5, end of quantity, squared. Let's go ahead and use our vocabulary to determine whether each original number is a perfect square. We have the number 144. That is a perfect square because 12 squared, which is 12 times 12, does equal 144. 49. 49 is a perfect square because 49 equals 7 squared, which is 7 times 7. 8 is not a perfect square. 8 does equal the square root of 8 squared, but that does not make it a perfect square. 6 is not a perfect square. Again, 6 does equal the square root of 6 squared because the radicand and the squared undo each other, but 6 is not a perfect square. 4 is a perfect square because 4 equals 2 squared, or 2 times 2. Now it's easy to solve a quadratic equation when taking the square root. We have a method that will allow us to write it in this form so it's easier to solve. It's called completing the square. You can solve any quadratic equation by completing the square. This method turns every expression of x squared plus bx into a perfect square trinomial. You complete the square by adding the quantity b divided by 2 squared to x squared plus bx, where b is the coefficient of the x term. So if we have the equation x squared plus 20x, what c can we add to make it a perfect square trinomial? Well, to do that, we need to take b divided by 2 squared. So let c equal b divided by 2 squared, where our b here is 20. So 20 divided by 2 is 10. 10 squared is 100. So replacing 100 in place of the c, we see that x squared plus 20x plus 100 is a perfect square trinomial. Well, since x squared plus 20x plus 100 equals x plus 10 times x plus 10, we know that x squared plus 20x plus 100 equals x plus 10 squared. Let's move on to see how we can use this. Before we look at Jamie's error, let's go ahead and solve x squared plus 9x plus 15 using completing the square. Now, you do realize that x squared plus 9x plus 15 is not in itself a squared. So the first step is to write it as x squared plus 9x equals negative 15. I did this by subtracting 15 from both sides. So now we need to determine our new c term, which will create a trinomial that's a perfect square. To get that, we need to realize that c is going to equal our b, which is the coefficient of the x, divided by 2 squared. So that will be 9/2 squared, and we're going to add that to both sides. The left-hand side of this equation will become x plus 9/2, that quantity squared, and the right-hand side will become 5 1/4, or 5.25. The next step is to square root both sides. The left-hand side becomes x plus 4.5, and the right-hand side becomes plus or minus 2.29. Now to solve this, we are going to subtract 4.5 from both sides. As you can see, by subtracting 4.5 from a positive 2.29, you get a negative 2.21. And by subtracting 4.5 from negative 2.29, that's a negative 2.29, you get a negative 6.79. Now, looking at number 11, can you determine what Jamie did incorrectly? Yes, she did not square her 9/2 before adding it to both sides. I would like to point out that this method of completing the square only works when a equals 1, when the coefficient of the x squared variable equals 1. If it doesn't, you can get it to that point by dividing the a term, the b term, and the c term all by the a term, so that the x squared coefficient equals 1. Here are the steps for completing the square. You may wish to cut this out and glue it into your agenda for notes. Step 1. Move the constant to the other side of the equation. Now your constant is the c term. And to start this process, you can only have the x squared plus the bx on the left-hand side. It can equal a value, but the only thing on the left-hand side must be the x squared plus the bx. Step 2. Take your b term, divide it by 2, and square it. Take that value and add it to both sides of the equation. Step 3. Factor. Now the left-hand side should be a perfect square of a trinomial, so you want to write it as a squared term. Step 4. Solve by first taking the square root of both sides. Remember, on the right-hand side you will have a positive and a negative value. And when you solve for x, you should have two different values for x. Here is an example. Step 1, move the constant to the other side. So I'm going to subtract 7 from both sides. So I have x plus 4, that quantity squared, equals the value of 23 minus 7, which is 16. I already have this factored into x plus 4, that quantity squared. So I'm then going to solve it by taking the square root. Square root of x plus 4 squared is x plus 4. And on the right-hand side, remember, I have 16, so the square root of that is 4. So I have x plus 4 equals plus or minus 4. I'm going to subtract 4 from both sides to isolate the x. So x is going to equal either 0 or 8. Why don't you pause this video, go ahead and try this using the 4 steps listed on the right-hand side, and then check back here to see how well you did. Step 1. Move the constant to the other side of the equation if necessary. So I have moved 33 to the right-hand side. Step 2. Add b divided by 2 squared to both sides of the equation. So I'm going to add 2 divided by 2, which is 1, squared, which is 1, to both sides of the equation. Step 3. Factor. Well, x squared plus 2x plus 1 is x plus 1 squared. Now step 4. Solve by taking the square root. As you see, I have subtracted 1 from both sides and get x equals 4.83, or x equals negative 6.83. And that's my solution set. My suggestion on example 3 is you go ahead and try to solve it, get as far as you can, and then check back here for the solution. First, I moved the constant, the 26, to the other side of the equation, so I subtracted 26 from both sides. Then I'm going to add the b divided by 2 squared, which is in this case going to be positive 36, to both sides of the equation. Then you'll see me factor. I'm writing it as a squared term. And then I'm going to solve by taking the square root and solving for x. You have a lesson check and a self-check. Go ahead and complete those. And I believe there's one more slide with the story problem. I do want you to at least read through that and bring any questions you have to class tomorrow.